Hello friends, welcome to this new video on direct displacement based design for RC frame buildings application using SAP2000 software. Welcome after a break of more than 1 month. Our immediately preceding video was on frame shear wall building. In similar way, it was the application on SAP2000 software. We shall take a problem and we'll try to solve it through SAP2000 software. So we have taken a 10-story building and the design depth is 2%. Hazard level is corresponding to 0.35 G of Eurocode for soil type B. And the height of story is 3.3 meter and ground story height is 4 meter. Yield strength of steel is given 500 megapascal. Size of beam is given 0.5 by 0.6 meter. Size of column is given 0.6 by 0.6 meter. Wall thickness is 200 millimeter. Slab thickness 120 millimeter. Outer wall is 1 brick thick and inner wall is half brick. Live load is 3 kN per square meter. So here is our plan, which is 3 spans of 5 meter and 5 spans of 5 meter. So it is a rectangular building and regular plan. Number of columns we can identify, then slab area we can calculate, length of beams we can calculate, and wall length we can calculate. These are the infill lengths. Wall means infill wall. So we compute the mass as we did in the last video. Find out all the weights and from the weights we calculate the mass. So we get that the mass per floor is this much, 552090 kg, and mass in the roof is 379510 kg. Now we can calculate the relevant parameters like equivalent single degree of freedom system properties. So we start with the shape profile. For number of stories greater than 4, the shape profile suggested by Pettinga and Priestley is this one. And the equivalent single degree of system properties are the design displacement delta D, equivalent mass ME, equivalent height HE given by this known formula. MI is mass in the ith floor, HI is height of the ith floor from the base of the building. Delta I is displacement at the ith floor level mass. Delta I is given to phi I, shape coefficient phi I into delta C by phi C. What is delta C? The critical story displacement given by theta D into HSC. And phi C is the shape coefficient corresponding to that critical story. What is critical story? We know where the height of the story is largest or where the mass is largest. Now we calculate the displacement profile, the value of delta I for different flow levels. Now we prepare the standard table for equivalent single degree of freedom system property calculations. This table is slightly different from those of the frame shear wall system. So we require floor and the height of the floor, then mass, then phi I, shape coefficient, then delta I, that was the formula we discussed, and remaining are the mathematical calculations only. So mi delta I square, mi delta I hi. Start. Now we prepare the table for equivalent single degree of freedom system properties. This table is slightly different from that of the frame shear wall building. So hi height, then mass, then shape coefficient phi I, and then calculate delta I by the formula we have just discussed in the previous slide. And remaining are only multiplications, etc. Mi delta I square, mi delta I hi. Then find the summations. From the summations we can calculate those values of delta D, mi and he by the formula we have just discussed. So delta D is 0.375 meter and mi is this and h is 22.440 meter. So calculated values just as mentioned in the previous slide these are the values. Now we go further, calculate the strain in the steel 500 by 2 into 10 to the power 5 is this much. Then the yield rotation of the frame is given by 0.5 epsilon y LB divided by HB. Our length of beam is 5 meter, depth of beam is 0.6 meter. So this comes out this much radian, 0.0104 radian. Now yield displacement is yield rotation into height. So theta yf into HE. So it comes 0.234 meter. Ductility is maximum displacement by yield displacement. Maximum displacement is delta D 0.375 and yield displacement is this one 0.234. So it comes out 1.606. Equivalent damping is given by the standard formula, and this comes out as 13.1%. Now we prepare the displacement spectra corresponding to our hazard level, which is European code 8 at 0.35 G level, soil type B, and damping 13.1%, as we have calculated the equivalent damping in the system. So we have drawn only a single spectra line, single displacement spectrum. Now you look at your displacement at the design delta D, design displacement, which is 0.375 meter. This is the line showing the design displacement. So wherever it is cutting this displacement spectrum, you draw a vertical line, and that gives you the equivalent time period. So it is here 3.83 second. So we have calculated the another property of the equivalent single degree of freedom system, the effective time period. Now the equivalent mass is this much as you have seen, and Ke, the equivalent stiffness, is given by 4 pi square me by T square. T just we have calculated, so this is coming as this much Newton per meter. So Vv, the base shear, is K into delta D. K is this and delta D from the previous expression. So this much Newton, or 3456 kilonewton. T you have seen, it is 3.83 second. Now we distribute this base shear over the floors. Distribution is very simple. You take up these columns HI, MI and delta I. From the previous table you can just copy paste and find out this value MI delta I and find out the sum here. So any force is given by this formula. For less than or equal to 10 story height of the building, this is the formula. Fi equal to Vv MI delta I divided by summation MI delta I. So simply by taking the sum and the Vv and MI delta I from this column, I calculate these forces Fy, and if I make a summation of the forces, it will show the correctness of this summation. This Vv should be equal to this summation. So these forces, just you have seen the previous slide, are to be put in the central nodal point of the floors at different floor levels, corresponding floors, and then you can start designing. Design is to be done with expected strength of the materials. For concrete it is 1.5 FCK, so 45 megapascal. Our concrete was 30 megapascal strength. Expected strength for steel is 1.25 Fy as per FEMA 356, so 1.25 into 500, 625 megapascal. These strengths are to be used not only in design, also in the analysis, non-linear analysis. Load combinations are simple: dead load, live load, and earthquake force we have calculated in the previous table along short direction, along long direction. The values are same, but you have to put them in the short and long direction, and that makes the combinations 5 numbers here. Now there is some problem with the SAP2000 software current versions. They are using SAP41, which actually has shown only the secondary values for the plastic rotation for IO, LS and CP. IO is alright, IO is same as in the primary and secondary, but LS and CP in the SCI41 document is given only for secondary elements, but our members are primary elements. So we go back to FEMA 356 and find out those primary element values, which are like this, depending on the shear ratio and other steel ratio, etc., which is not shown in the left hand side. Now for your each of the member, you do not know the parameters like shear ratio, steel ratio, etc. before design. So this exact value you cannot set to the hinges. So what you do as an average, you take the average values of this IO, this much radian, for LS this much radian, and for CP 0.02 radian. These are the average values. It will lead to some approximation, but there is no other way before design. So these values, when you use the SAP2000, it will automatically give you the auto hinges with SCI41 hinges. So those will be for secondary elements. Those hinges you have to modify as a user hinges with these values of the IOLSCP that can be done in the software, and those become user modified hinges which are to be applied in the beams column, etc. Now after you calculate, let us go back to the SAP2000 software. So this is my model, this is the 3D model frame, isometric view, and this is the plan. At level it is second floor, 7.3 meters, second floor. So in the sections we have used like this, frame sections, beam and column. Wall we don't require, we can delete those properties. So beam, if you show here, 0.6 meter deep by 0.5 meter wide, and column section as given in the question, 0.6 by 0.6 meter. Now columns we have not changed it, along the height of the building, which is actually approximation, and it will not be economical, because at the higher floors the forces are less and you can reduce the size. That we have not done for the sake of brevity. So this is my section properties. Then material I have used. Material is M30 and HOSD500. So if you go to M30, the properties are given here. The C properties we have not given 30, but we have given 45. Okay, if you go to Newton millimeter, we have given 45, the expected strength. And similarly for steel HOSD 500, see, it is 650, not 500, the expected strength we have used here. So these are to be used so that the non-linear design, the damage based design is possible. Then we have put different loads you can show or not. Let us see whether it is already in locked condition, because the analysis results are there. So display load, let us see, show. Let us see, yeah, some loads are coming here. Say slab dead load, apply. No, in the run state, the sample is under load condition, the analysis has been run, so it will not show the load diagrams here. Anyway, then we have run the analysis. Let us see the load cases. In the load case, you see these are the load patterns given. Then this Fx is the horizontal seismic force, and this is the horizontal seismic force in the 90-degree direction, y direction. And you have to take initial state for the pushover analysis, and for nonlinear time state analysis also that will be required as a gravity load. So if you see this case, modified show load nonlinear time state analysis, we have used the shorter direction, which is u2 or y direction in the plan. You can see here x is along the long direction and y along the short direction of the plan. So you have to use here u2, and this is the function we have used, SCGM, spectrum computable ground motion, and scale factor we have used. With this we have carried out the time state analysis and found out the outcome, the displacement histories. This you can see in the Excel sheet. For different floors, depending on the time, and these are the displacement values. So these are time history results for all the floors. From the time history results, taking the difference between any floor and the immediate previous floor, and dividing it by the height of the floor, you get the idea, interstory drift values, ratios, and you can multiply by 100 to get the percent. These are percentage values I have calculated, and these percentage values I have drawn here for the interstory drift diagram. You have to make a little manipulation here, so the drift diagram is coming like this in a straight line zigzag way. In the diagram I have also shown the target drift. So let us go back to the original file again. Yeah, this is the drift diagram, and target drift was 2%. Now you see actual drift is much lesser. Why it is so? Because our building we have not made it economical, we have used arbitrarily size 0.6 by 0.6 meter column and some size of beams which are actually not the desirable sizes. You can iterate and get the correct sizes. So in the direct displacement based design, the method is not telling you anything regarding the choice of the initial member sizes. So you have to make many iterations so that you arrive at correct size, and then perhaps the drift diagram may be coming near to this target 2% drift. I have tried only one time ST here. You have to actually use around 11 times ST. So 11 diagrams will come, and some of the diagrams will be in different drift values, may be coming near to this. However, with the present condition of the building sizes of the members, it will not come near to 2%. It will remain within 1%. So the building we have designed is not economical. You have to make iterations to get the sizes. Let us see the hinge conditions now. These are the hinges formed in the beams. The columns are not forming hinges because of the capacity design. In the capacity design, we allow beams to form hinges and not the columns. So columns are elastic, and from the color, the pink color, you can understand that it is corresponding to this up to IO. So this building is in the IO state. You can also see it in this diagram. You under NLTHA and last time if we give and we apply it, so it is showing the hinges in all the members in the 3D diagram. And if you want any 2D values, you can go to XZ, or in this direction we have not run the time ST. The long direction it will not show. It will show in the short direction. So in the short direction, these are the frames. You can navigate between the frames one after another with this. So this building we have designed for 2% drift, and we have got conservative value of the drift because we have not applied iterations for improving the size of the members. Thank you very much. I think this will highlight you how to utilize the direct displacement based design for RC frame buildings. One thing you have to keep in mind that the direct displacement based design does not give you the member sizes. No hint regarding member sizes, and as such you need more and more iterations to finally get some size which will be economical and at the same time meeting your need. So process will be lengthy because you have to run 11 times STs for any given size of the beam and column, then see whether it is exceeding the target drift or remaining within the target drift, economical or uneconomical. If not, then you run another design, then another 11 times STs and so on. So it is a very lengthy process to get the ideal condition. We'll see that this can be overcome in the unified performance based design EPBD method for both frame buildings and frame shear wall buildings. There you get the member sizes in the beginning of the task and you need not iterate. Thank you very much. So please subscribe this channel, like and share the videos, put your comments in the comment box so that we can discuss further on the topic. Thank you.